this ball. And it's going to have components of that much in the x and that much in the y. So this is going to be the delta x in ball 2's velocity. This is going to be the delta y, this distance right here. This distance right here. Okay? And this is theta. And so with theta, what this is giving us is a relation. Theta is a relation between the change in the y velocity and the change in the x velocity of this ball. And that's how we're going to bring theta into our system of equations here to add as a constraint. And so let's be clear, I'm not going to expect you to derive these equations. I do expect you to know them though. So if you write them down. You don't have to derive them, you only have to apply them to something. Alright? So what we can say here, so if we know this is delta y, that's delta x, that's theta. What's a trigger equation that relates these things?
Tangent.
The tangent, yes. Tangent. So we have the tangent of theta equals opposite, so delta y. This is of v2, delta y v2 over delta x v2. So that's our relationship. And so what is delta y v2? Delta y, let me rewrite the subscript actually. We have delta y just 2 really. So delta change in the y velocity of ball 2 to there. That's what it should be. So it's sub 2. It's the change in the y velocity of ball 2 or the change in the x velocity of ball 2. So what is the change in the y velocity? Using the notation we've got all up here. We have u2x and u1x, u2x, u2x, and so on. What is the change in the y velocity of ball 2? There is no v. There is no v. Because this is the change in the y velocity during the collision. That's what this is.
So v2y minus u2y?
Yes. Yes, indeed. That would be the change in the y velocity. So the top part of this is going to be v2y minus u2y. That's the change in the y velocity. This is what it was after. This is what it was before. Okay? And so what would be the change in the x velocity? Same thing with x. So v2 sub x minus u2 sub x. So that's our fourth equation. We have tangent theta equals this right here.
Delta vy2 or delta v2y?
No, because the v isn't changing. The v is fixed. The u's and v's are fixed. The change is from when we're going from u to v. That's the change. Okay, that's why I miswrote this the first time. Okay, so this right here is our fourth equation. We now have 4 equations and 4 unknowns, which we can solve. So if I were to give you M1, M2, I gave you U1 and U2, either in maybe I might break it out into the X and Y components, or maybe I give you a magnitude and an angle. I probably would make your life easy, and I'd probably just give you theta, although maybe not. I might ask you to figure it out one way or another. You would all be able to solve this, right? Why?
We have the sheet, like a sheet with notes. What about?
Yeah, you're gonna shoot notes. You have all everything written on the board. You would have in your notes. I will. Everything presently written on the board, you could have in your notes.
Well, solve problems.
Well, then you have to solve a problem. So that's the thing. I mean, the problem's going to vary. The numbers are going to vary, right? I mean, I can maybe work them through a lecture, but I'm not going to give you
angle for U1 and U, or for U1 X and U1 Y.
So you mean like, you could say the angle here, that angle, and then maybe, I don't know, we've measured this, that angle?
Yeah, something like that.
Yeah, those are all three different, they're all three different angles.
So then for B1 would be a different angle too.
Yeah, I mean, these are gonna head off at whatever angles. So if I were to give you, as I said, I gave you that, you guys would be able to plug it into these equations and solve it out and give me V1 sub x, V2 sub x, V1 sub y, V2 sub y. Yes?
Yep.
Perhaps an example would be.
I mean, come on, it's 4 equations and 4 unknowns, what's hard?
Let's go, Walt.
So wait a second, if we're,
That's your problem.
you're giving us U, you're giving us M, but you're not giving us V1 or V2?
That's what we're trying to find, remember?
So we're trying to find V1
We
and
want,
V2.
I wrote an angle over it. So this stuff's known. M1, M2, U1, U2, however I find them, either with magnitudes and angles or by just giving you their X and Y components. One way or another, they're known. And we want to know V1 and V2. Okay? And so I've given you that. I've given you 4 equations. There's just 4 unknowns. You should all be able to solve it. Yes?
Might take a little bit of time, but yeah.
Yes?
So why from the delta y to y
Delta y1. We could have set it up with delta y1. It's just
So
it would be
how
not
do
be
you
an independent
So
equation.
you have to find the
Okay,
change
so
in
you're
V,
gonna-
and then,
You're talking about this guy right here?
Yeah, so you just did
I'm just
that
not,
equation
how do
just
we
derived from-
differentiate?
That's,
So we have V1
ah,
and V2,
this
the
right
first
here.
equation. We
I
have
could
V1
do it
and
the
V2,
other way.
and the
I
second
could say
equation.
force on
And
this
then
guy,
there's the
and I could
change
set
in
it
V.
up with the change in the velocity of
And
U1, and that would be fine,
not
but it's not an independent equation with this one. Those two are dependent. It said with your constraints, they have to be independent equations. That's why we couldn't use Adams throwing more momentum equations of this. They wouldn't be independent. Each equation needs to be independent.
So that equation's the same for V1, you just plug in V1 value for the Y.
If I were to do it with V, pretty much, yeah. There might be a little bit of sign stuff, but yeah, basically.
Do we need to know the force?
No, I was just showing, saying that, trying to explain why this is the change in X and change in Y. We don't need to know. All we have is we have tangent theta equaling tangent theta equals this stuff right here. I mean, the theta is one of our givens.
Okay.
So as I said, we have 4 equations, we have 4 independent equations, we have 4 unknowns. It should be totally solvable, and I can expect you all to do it on the exam and that'll work.
Does anyone else not have a freaking clue?
Yeah, no.
Can we do it
Can
again?
you like demonstrate how to solve for like one and the other?
Notice that he's just sitting up there.
All right, okay. I've been playing with you for a little while now, and I'm gonna bring it to an end.
I don't
You
see how
should
you're
do
gonna
like
get
a bonus,
B's.
a bonus problem for extra points or something.
All right, so here's the thing.
For that.
Here's the thing. Hey, slow down. So we do have 4 equations, we do have 4 unknowns, and that is enough information to solve the problem. All right? It is solvable. However, an analytic solution is not possible. All right?
What is
Question,
that?
Brendan? Let me finish. Okay, so you know, you guys know what quadratic formula is, right? You vaguely remember it? All right? And so, you know, you have some, you know, y equals 5x squared plus something else in x plus 2, or whatever it is, okay? And so then you take the various little constants for the x squared term and the x term and then the constant, you drop them all in, you prove the quadratic formula and you solve it out. And you get possible values for x. You get positive 1, negative 1 kind of, right? So that's because those are non-linear equations. When you have y equals 6x squared plus 7x plus 9, okay? That's a nonlinear equation, meaning the relationship between y and x is not, if you were to plot this, we have x, we have y, it's not linear. Yeah, it's going to do something. Yeah, and the way I wrote it out, yeah, have here, because we have all this squared business going on. The rest of them, that's linear, and that's linear. This one's not linear because we have a tangent, and that one's not linear because we're squaring a whole bunch of stuff. So we have nonlinear equations. And because we have nonlinear equations, well, okay, let me, if they were all linear, and you guys all had linear algebra, which you, I'm assuming not, maybe Brendan has. If you had linear algebra, you could set these up in a matrix, do some clever linear algebra tricks, and you could solve it out. Okay, you could get an actual solution to this problem. So when I say analytic, an analytic solution is one that you can figure out with equations. You do manipulations with algebra, maybe you do some linear algebra, maybe you do some trig, maybe you do some calculus, but you do use equations and you get to an answer. And so like the things we've been doing before with my, my shooting a guy with a shotgun deal, that was an analytic solution that we came to. With this, if they were linear, as I say, you could do linear algebra and you could solve it analytically and come to a precise solution. Because these are nonlinear, with these guys being squared and that being a tangent, you can't solve this analytically. Okay? You have to solve it numerically, which is to say, use a computer. And so the way back in the day, 100 years ago or more, when people wanted to solve equations like this, because people did. People had nonlinear equations that they had an interest in coming up with an answer to, but they didn't have a computer to do it for them. What they would do is they would guess. They would guess. They would have a look at it and be like, I kind of think V1 and V2 are going to be this, and I'm going to throw some values in there, and I'm going to solve out my 4 equations, and I'm going to see if they work. I'm going to plug some values in. I'm just going to guess. I'm going to guess for V1 sub x, V sub 1 sub y, V2 sub x, V2 sub y. I'm going to plug those into all 4 of my equations, and I'm going to see how close they are to working. And they're not going to work with my first guess. And so then what I'm going to do is I'm going to go, okay, all right. So that one didn't work, and I'm going to try again.
Guess and check.
What's that?
Guess and check.
Yeah. So I'm going to guess again, and I'm going to plug them in. And I'm going to guess again, and I'm going to check. And because I'm an exceptionally clever person, because there have been very clever people throughout the history of people, I'm going to come up with some very clever ways of guiding my guessing. Okay? They can potentially involve the equations you're looking at. They can potentially involve the trend in the answers. You'll okay, maybe I'll just leave V1x, V2x, and V1y all the same. I'm just going to mess with V2 sub y. I'm going to put my initial guesses in. I'm going to mess with this, and I'm going to see how my answers trend. And if I increase this, how do the answers sort of move? Okay, is it improving things like if I increase this? Which equations is it improving? Which equations is it making worse or less true? Okay, and so I'm going to use all that. I'm going to be very, very clever, and I'm going to come up with some ways to give me a way, some indications as to how to guess. So I put my first set of numbers in, didn't work. I do some more. Eventually, I can maybe get some ideas on what direction I should go with my guessing, and I keep doing it. I keep guessing until I'm like, yeah, okay, this is close enough. I come up with a solution. It's not dead on. I'm not. I kind of have values for V. I have values for these 4 guys, which is what we're trying to find. V1 sub x, V2 sub x, etc. These are the ones we're trying to find. I have values. When I put them into the equations, they don't perfectly work. The equations don't not perfectly equal, but they're pretty darn close. And I say, okay, this is good enough. I've come to a solution within a certain error tolerance. Yeah,
Could we solve this? Could we do
by guessing.
Is there any way to solve it?
I'm going to continue my little spiel here. Okay? Anyway, so you do your guessing. As I said, you're very clever. And if you look up, there's like, some of you ELM guys may have heard of some of these methods. Newton Raphson, there's a bunch of different methods. Basically named the guys from a long time ago who came up with them for how to do the guessing. And you keep doing it until you're happy. Until you say, okay, in my judgment, this is close enough, it'll work for me. A computer does the exact same thing. So if you are going to solve this with a computer, which is how you would solve this, the computer guesses. It just guesses a lot faster. Because it can calculate these equations more quickly. And it also, again, depending on what solver, see what you're going to use is you're going to use program, it's a solver, and it has, again, like I was saying, it has these techniques to guide the guessing. These are called algorithms, solver algorithms. And it will have one, there's different ones you can use, because some work better for certain sets of problems. You can throw different ones, different algorithms at it. Some algorithms you'll say like it doesn't converge. It ain't working for me. The computer will give you, it'll like sit there spinning its wheels for a while, and then it'll say, can't find a solution. Because the algorithms it has for guiding the guessing aren't working. They're not coming up with something that works. Yeah.
I remember doing something with